So let's look at a polynomial. So a polynomial function. Now we've already been working with polynomials. We worked in extensive detail with a quadratic, and we've been looking at cubics. A quadratic is just a second degree polynomial, and a cubic is just a third degree polynomial. Now, the second degree, third degree is going to come into play in this chapter, and the polynomials are defined by their highest power or their degree. So if we look at this example here, this is a fourth degree polynomial because the highest power is x to the fourth. A couple things to note about polynomials is we always write them in descending order, highest to lowest that is, and the highest power is the degree. So this is a fourth degree polynomial. Now, what we're going to do is we're going to look at dividing polynomials. Before we start dividing polynomials, we have to look at dividing numbers, or just numerics here. So we're doing long division. So if we have 21, and we're trying to divide that into 67, and this is a grade 6 or grade 5, or maybe even kindergarten problem, is we look to figure out how many times does 21 go into 67. And we say, okay, 21 goes into 67 3 times. 3 times 21 is 66. Sorry, 63. Got to get that adding the multiplication right, and then we subtract. 67 minus 63 is 4, and then we bring down the 9. So 21 goes into 49. That's twice. 2 times 21 is 42, and we have 7 left over. Now, there's a couple things here. We have certain names for these things. We have this thing right here, which we call the divisor. Of course, we have what's left over. That's our remainder. We have our solution, which is our quotient. And what we're dividing into is our dividend. So those names are going to come in handy because we're going to look at those. Now those apply if it is numbers, like in this case, or if we are dividing a polynomial by a polynomial, like we're going to do right here. So let's recall from doing long division. We're dividing a polynomial by long division. Now remember, this time what we have to do is we have to figure out how many times does x go into x cubed. That's all we're concerned about when we're dividing a polynomial by a binomial here. So x cubed divided by x is just x squared. So we're just going to line up the x squareds. Now, same thing as we did before. X squared times negative 5 is negative 5x squared. And x squared times x is x cubed. And what we always do is once we've multiplied, we subtract. So x cubed minus x cubed is 0. Negative 2x squared minus negative 5x squared is 3x squared. And then we bring down this negative 33x. We do it again. 3x squared divided by x gives us plus 3x. And remember, anytime we have this number up here, what we want to do is we want to figure out this number times this value always has to equal this thing right here. So 3x times x equals 3x squared, because when we subtract, they're going to disappear. 3x times negative 5 is negative 15x, and then we subtract. And we're going to get 0x squared, which is exactly what we want. Negative 33x minus negative 15 is negative 18x. We bring down the 90, plus 90, and negative 18x divided by x is negative 18. Negative 18 times 5, negative 90. Positive 90 is what I should say. And negative 18 times negative x is negative 18x. And lo and behold, when we subtract, we get a value of absolutely nothing. So remember, we can write this as the quotient, which is x squared plus 3x minus 18 multiplied by the divisor, which is x minus 5, and that's going to equal our dividend, which is our polynomial in this case, the number underneath the quadrat or the division sign. X cubed minus 2x squared minus 33x, hopefully you haven't run out of room like I have, plus 90. So that's how we can write our polynomial.